We are going to revise LSM1013 CLO3. This CLO talking about the trigonometry. So we are interested in the right triangle. Without the right triangle, which has one angle has 90 degree or pi over 2. Without this angle, you cannot talk about the sine or cosine, right? So you have to guarantee you have a right angle to have the trigonometric functions. The first one is called sine theta. Sine theta is the opposite. Here is the theta. Opposite over the hypotenuse is called sine theta. Cosine theta is the adjacent of the angle theta over the hypotenuse, right? Tan theta is just sine over cosine. So when you divide it sine by cosine, you will cancel out the hypotenuse with the hypotenuse, so you end up with opposite over the adjacent. Don't worry, everything is there in the formula sheet. This is what we call it reciprocal for the sine and cosine, right? It means 1 over sine, we call it cosine. So 1 over the function sine theta, we call it cosec theta. So it is 1 over sine, which means hypotenuse will be up and the opposite will be down. Also, cosine theta is 1 over cosine theta, we call it sec theta. So the one with S, 1 over this one will be start with C, right? 1 with C, 1 over the cosine is sec, which start with S. Don't worry, all of these kind of things are in the formula sheet. But without the right triangle, you cannot talk about the sine and cosine or sec and cosec or tan. Cotan is cosine over sine, right? Okay. Let's go for the unit circle. If you have a unit circle, it means the value of x is equal to 1. And also the value of y here is equal to 1, right? Now, the radians measurement for the angle is the length of the arc over the radius of the circle, right? So we have two types of measurement for the theta, the degree or the radians, right? Now, if you have a unit circle, it means you have a triangle like this one, right? So the sine theta is, yes, if you have a point A and B, right? Say this is A and B point. So B is the Y, A is X, right? And we have the right triangle here, okay? So sine X is the opposite over the adjacent. The adjacent is the same as the radians here. So A here is 1, right? Okay, so using the unit circle, you can find sine and cosine. And remember, the radians is 1, okay? Tan is the opposite over the adjacent, right? So it will be B over A, right? So be careful. If A is equal to 1 or B equal to 1, like here and here and here and here, right? So all of these function will be in the formula sheet. Okay, this is what we call it reciprocal and quotient identity. Reciprocal, it means 1 over the basic function, sine and cosine, right? 1 over any function is called the reciprocal function. Okay. Now we have a right triangle here. Okay. What we can say about this one, when you replace x by minus x in any function and you have the same value, it means your function is even function, right? Okay. This is what we call it Pythagoras, right? Identities. Sine square for an angle x plus cosine square for the same angle is always 1. From this one, if I divide it by cosine square, I will get this one, right? Because cosine square over cosine square will be 1. Sine square over cosine square is tan square sec. 1 over cosine square will be sec square. So don't worry, if you have this one, you can find the other two. But don't, all of these one are in the formula sheet. Okay. Now, this is the wrapping point. If you notice in the wrapping point, for each one here, if you square the x coordinate and the y coordinate here, so square this one and square this one over 4 plus 3 over 4 will be 1. Any wrapping point here, if you square this one, it is 1 plus 0. So the sum of the two square is equal to 1 for any point. This is what we call it wrapping point, okay? So what is a wrapping point for minus pi over 2? What is minus pi over 2? This is pi over 2. The opposite one, we can call it 3 pi over 2 or minus pi over 2, the same thing. Because almost we anti-clockwise, we make it positive. With clockwise, we make it negative angle, right? So we can start from 0 and end up with pi, and down from 0 to minus pi. Or you can make it 2 pi or 360. Any two coordinate here, if you square each one and sum them, it will be 1. So the wrapping point of minus pi over 2, the same as 3 pi over 2, I have 0 and minus 1. So, and for 7 pi over 6, what's 7 pi over 6? 7 pi over 6, it is exactly like pi and pi. Up to here we have pi. Pi over 6 is here, so we already, this is the 7 pi over 6 wrapping point. So the wrapping point, you catch it from the formula sheet from this wrapping points graph. Now, how I can check this is the correct value of the wrapping point? I'm going to square, as I said, the x value and the y value and take the square root of the sum of the squares. If I get 1, this is a wrapping point. This is exactly what I've done. I square the x value plus the square of y value, take the square root, I get 1. So this is our wrapping point. He's asking me to find the find the six trigonometric. The six trigonometric functions is sine, cosine, tan, cosec, sec, and cotan, right? So if I have A and B, I know sine x, if I'm working in the unit circle, this means we are in the unit circle. Okay? So I can go and find sine x as B at this one, right? And cosine x is A. Once I have sine and cosine, I can find the rest from the formula sheet, giving me tan x is sine over cosine, so I divided this one. If I need cotan, I divided cosine by sine. If I need sec, sec is 1 over cosine. So the main issue to find the sine and cosine. Okay. Now, I have something called period and amplitude. If I look at cosine, cosine have this one repeated each 2 pi, right? Each 2 pi you have the same shape, right? Also, the sine function had the same period, right? So the period is where the shape repeated, right? If I start from 0 to 2 pi, I find from 2 pi to 4 pi, I have the same shape, right? What about the height for this function? or the y absolute value. So -1 to 1 is the amplitude. So the amplitude is the height of the function. The period is where the function is repeated. Okay. Now, if you have in general y equal to this one, the amplitude will be the absolute value of the coefficient over your sine and cosine, and the period, take the coefficient of x inside the sine and divide 2 by this coefficient. This is how to find the amplitude and the period. Okay, easy for sure. I'm saying I'm not going to take this one. I take the absolute value just in case if I have minus outside. So this is the amplitude. And I take this one and divide it by 2 pi to have the period, right? Catch it? Okay. Now I know how to find. This is the amplitude. I take this one and divide it by 2 pi to have the period, right? Now, if I would like to verify something like this one, I have to use from the formula sheet, I have to replace this one by the correct one, right? So it is easy to change everything into basic function sine and cosine, right? Okay. Now I end up with, yes, after I finish, I replace the value of sine, right? How I did replace the value, I cancel out this one or this one. So I have only here, because cosine minus x is equal to cosine x, so I can cancel out this one. So I end up with 1 minus sine over minus sine x. I have sine x is given for me, so this is the value for this algebraic term. How to verify this one? First, keep sine, because this is the simplest one. Cotan is cosine x over sine x. So I cancel out this one. So I end up with cosine x. This is correct. The left-hand side is equal to the right-hand side. This is how to verify. Now, also, leave cosine x because it's a basic. What is the sine? Sine is, tan is sine x over cosine x, right? So when I substitute this one from the formula sheet, I end up with, cancel out this one, I end up with cosine x, which is the left-hand side. So you start from the right-hand side, simplify it up to the formula, okay, and then you end up with the left-hand side. So this is how to verify any identities. If you are given sine and cosine, and he's asking you for cotan, you know cotan from the formula sheet is cosine x over sine x. Just plug in the numbers now. Yes, this is a cotan x. Yes, if you are given sine x, is asking for cosec x. Cosec is a reciprocal for sine x, which means 1 over sine x. Now I have sine x, 1 over 4 over 7, which is 7 over 4. Right? Yeah, that's correct. Now, also, if you are given sine, half, sine x is half, and he's asking for cosine minus x. Cosine minus x is 1 over sine minus x, because sine minus x is odd function, it's 1 over minus sine x. Now, plug in the number for the value of sine x, which is half, so you can get the answer here, -2, right? This is exactly what you are going to do. This is how to work it out. So I think now you can also do this one, right? You can use this one to verify any one of these, right? So I will leave it for you. Give it a try. Okay. Thank you so much. Wish you all the best. Thank you.